Welcome guys to my YouTube channel. You are welcome to today's video lesson. As you can see on the board, we are doing Jamb chemistry questions part 4. A lot of persons have been awaiting this part 4 of this video lesson. Sorry we couldn't make a video last week because last week was Easter week and then we wanted you to enjoy your Easter. But right here today, we are going to take the part 4 of the Jamb chemistry questions. So we are going to start with question number 24. Question number 24 says, the electronic configuration of the ion is what? The electronic configuration of the ion is what? Now, it is very easy to answer this particular question. Remember, in electronic configuration, you learn of your SPDF notation. And one of the laws that guides the SPDF notation is your IUPAC's principle. Remember, IUPAC's principle states that your electrons are arranged step by step. That is to say, when filling orbitals, electron must go into the orbitals of lower energy before those of higher energy. That's what IUPAC talks about. So according to IUPAC principle, we were told that these orbitals are in different energy levels, which I'm going to give to you now on the board. Now, you have 1x followed by your 2x followed by your 2p, and then you have 3x followed by your 3p, and then you have 4x followed by your 3d. For your first 20 elements, the electron ends in the s orbital, the 4s orbital. For the first 20 elements, that is from hydrogen to calcium. Then when you get to your transition metals, which is from your scandium, which is number 21, so infinity, we have the d orbitals. Okay, so if you watch very well, you'll find out that the question on the board have an atomic number of 22. It has an atomic number of 22. That is to say, it is not from the first 20 elements. It is from your transition, your first transition series. Remember, the transition elements are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, and so on and so forth. Okay, so if you watch very well, you find that this is the 22nd element of the periodic table. The 22nd element of the periodic table is titanium. Okay, now titanium has an atomic number of 22, and if it has an atomic number of 22, remember that you have 2 plus here for titanium. If you have x raised to the power of 2 plus and you have 22 here, the 2 plus here means that it has lost 2 electrons. So the number of electrons was supposed to be 22. Because it has lost 2 electrons, the electrons that will be left will be 22 minus the 2 that it has lost, which will give us what? 20. So that the electronic configuration for titanium has to do with 20 electrons, no longer 22, because it has lost 2 electrons. For your notice class, if you see positive, it means it has lost. But when you see negative, it means it has gained. So for this particular question, it has lost how many electrons? 2. Okay, now if I may ask, how many electrons has the ion lost in this question? As you can see on the board, it has 3 electrons. So if here was 13 before, and you have 3 plus, it means it has lost 3 electrons. So the number of electrons here will no longer be 13 to now be equals to 13 minus 3, which will give us 10. Okay, so as for this particular question, it was supposed to be 22, but because it has lost 2 electrons, it becomes 22 minus 2 to give us what? 20. So we are going to arrange 20 electrons in IUPAC's principle, which is the energy level of the atom, the SPDF notation. Now, what you should know is this. Remember that in your SPDF notation, your SP d and f. Remember that the maximum electron that your s orbital can carry is 2, and that your p orbital can carry maximum of 6, your d orbital can carry maximum of 10, while your f orbital can carry maximum of 14 electrons. So if you are arranging these electrons, you must ensure that for every s orbital there should be a maximum of 2 electrons so that you don't exit out. Okay, now if the atom given on the board is given this way, x2 plus 22, the number of electrons that we are going to arrange is equals to 20. Like I told you, 22 minus 2 to give us 20. You are removing 2 because it has lost 2 electrons. So the number of electrons left is what? 20. Now let's arrange 20 electrons into the electronic configuration that we have on the board according to IUPAC's principle that told us that electrons are arranged step by step. Remember that this is 1s, so it can take a maximum of 2 electrons. When that is done, you transfer the other electron 2. You can't put more than 2 in x. Okay, p will take a maximum of 6. And if you watch very well, you have 2, 2, 6, which will give us 10. We still have 10 more electrons. So you can put 2 here, which is 12. You put your 6 here, which will give us 18. And you put the remaining 2 here, which will give us what? 20. Okay? So the electrons does not enter the d orbital because the atom has already lost 2 electrons. Ordinarily, there would have been 2 here for titanium. So let us look at the board and see the answer to this particular question. Okay, this is similar to the electronic configuration of calcium atom. Okay, let's look at the board and see the answer to this question. Remember, there's no electron in the d orbital, so we can remove the d orbital. If you watch very well, you have d orbital here, so we cancel this option. We cancel this option. This one does not get to the 4x, so we cancel this option. Our answer is what? D. Thank you. Now let's take the next question. 16.8 grams of sodium hydrogen trioxocarbonate for 16.8 grams of sodium hydrogen trioxocarbonate for 16.8 grams of sodium hydrogen for is completely decomposed by heat. Calculate the volume of carbon dioxide given up at STP. Okay, now remember, this guy is your baking soda or your baking powder. Let's decompose this compound and see what it's going to give us. Remember, this is a stoichiometry problem, so you have to be careful in balancing the chemical equations. Let's do this quickly. Sodium hydrogen trioxocarbonate 4. Now, according to what we were told, you should know that whenever a metallic hydrogen carbonate decomposes, what you are going to get is a metallic carbonate plus water plus CO2. For instance, if I have calcium hydrogen trioxocarbonate 4, if this compound decomposes, I must have CaCO3 plus H2O plus CO2. This is the product. So the decomposition of metallic hydrogen trioxocarbonate 4 will give us this, this, and this. So there must be carbonate, there must be water, and there must be carbon dioxide. So let us apply that principle in demystifying this question on the board. Okay? Sodium hydrogen trioxocarbonate 4, also called baking soda or baking powder. Baking soda or baking powder. If this compound decomposes, you are expected to have sodium carbonate plus H2O plus CO2. Now, after doing that, you must learn to balance your equation, otherwise you are going to solve spoil. Now, let us balance this equation. You have, in this place, in the product side, you have 2 sodium here, and here you have 1 sodium. So you are going to put 2 here. There will be 2 sodium to balance it. And then you have 2 hydrogen here, which is giving you 2 hydrogen here, okay? Carbon is 2. You have 1 here, you have 1 here. Oxygen is 2 times 3 to give you 6. 2 times 3 to give you 6. So you have 3 oxygen, 1, 2. Wow. The equation is what? Balance, okay? Now, if you have balanced the equation, let us look at the question again. It says 16.8 grams of Sodium hydrogen triazocarbonate 4 is completely decomposed by heat. Calculate the volume of carbon 4 oxide. Now, the question wants you to focus on this particular compound and the carbon 4 oxide. So in this particular question, this one is not necessary. Your water is not necessary because the question says that you should calculate for the volume of carbon 4 oxide that is given up at STP when this compound decomposes. So you remove the ones that are not necessary. So what we have is your carbonate and your carbon 4 oxide. That's what we are going to focus on. Now, after identifying that, you should now check the kind of stoichiometry problem, okay? Because the question says that 16.8 grams. So they gave us mass of this compound. They gave us the mass. And they say we should calculate for the volume of carbon 4 oxide. So does it not suggest to you that if they gave us mass here, mass was given to us here, and we are told to calculate for the volume of carbon 4 oxide, volume, does this not suggest to you that this kind of problem is called the mass-volume relationship? Now, if you have established the fact that it is mass-volume relationship, please do not touch the numbers given to you in the question. The first thing to do is to first of all calculate for the molar mass of this compound, and then you get the volume of this compound at STP. Okay, what's the molar mass of sodium hydrogen triazocarbonate 4? Let's quickly calculate that. If I have 2 moles of sodium hydrogen triazocarbonate 4, it will give us, remember there's 2 here, so you have 2, open bracket, sodium is 23, plus hydrogen is 1, carbon is 12, oxygen is 16 times 3. Let's close our bracket. So we have 2, open bracket, 23 plus 1 is 24. 24 plus 12 will give us, okay, let's do this first, plus 48. So let's add all the values together and multiply by 2. 23 plus 1 plus 12 plus 48. So that will give us 84. So you have 2 brackets 84, and that will give you 168. Let's confirm that. Yeah, you have 168 grams. So the molar mass of sodium hydrogen for 2 moles, not 1 mole, 2 moles, because that's what we did, we multiply by 2. So what we have now, because we have mass to volume relationship, we can say that the molar mass of this compound is 168 grams to the volume of carbon 4 oxide. What's the volume of carbon 4 oxide? Remember, this carbon 4 oxide is just 1 mole. And the volume of 1 mole of a gas at STP is what is given to us as 22.4 dm³, okay? So, if you have 1 mole here, you use 22.4. But if you have 2 mole, you would have multiplied this guy by 2. If you have 3 mole, you multiply this guy by 3. So, let's do that quickly. So, you have 22.4 dm³. H2O is not multiplying it by 2 because what you have here is just 1 mole. If you have 2 mole, you multiply 22.4 by 2, okay? Now, let's do this quickly. If 168 grams gives us 22.4 dm³, according to the question, it said what will 16.8 grams of the compound gives us? So let's do that. 16.8 grams will give us what? X dm³. So what do we do here? We simply do what? Cross multiply. If you cross multiply, you have x times 168, so 168x equals to 16.8 times what? Multiply this with this, you have 22.4. So we divide both sides by 168. We divide there by 168. This what this x is equals to 16.8 times 22.4 then divide by 168 will give us 2.24 dm³. You have 2.24 dm³. So what we have here is 2.24 dm³. So the answer is not A, It is not B. The answer is what? C. Okay? We have more questions because I told you we are going to round up the Jamb mock chemistry questions in this particular video. So stay with us to the end of this video. Let's take other questions. Question number 26. 117.0 gram of sodium chloride was dissolved in 1 dm cube of distilled water at 25 degrees Celsius. Determine the solubility in mole per dm cube. This question is very specific because we can either determine the solubility of a compound in dm cube or in mole per dm cube or gram per dm cube, and I'm going to give you the two different formula. Okay, now if you want to solve solubility problem, the solubility number one can be calculated. Solubility can be calculated in mole per dm cube. Solubility can be calculated in mole per dm cube by using the formula mass of solutes dissolved all over molar mass of the solute times 1000 all over volume of the solvent or solution. Volume of the solvent. Please, now, because you have 1000 here, your volume here must be in cm cube. Take note of that. Your volume here must be in cm cube. Because of this 1000, it must be in cm cube. Then the second formula for solubility is that solubility can be calculated in gram per dm cube. In gram per dm cube, you have mass of solute. Please write this formula down so that you can use it to solve subsequent problems in your exam. Mass of solute over mass of solvent, mass of solute over mass of solvent times 1000. So we have two important formula for solubility. Our solubility can be calculated in mole per dm cube or in gram per dm cube. In mole per dm cube, you have mass of solutes that dissolve, not the mass of the solute, but the amount of the solute that has dissolved in the solvent, all over molar mass times 1000 over volume of the solution or solvent. The second formula is that solubility in gram per dm cube is mass of solute over mass of solvent. I want to say a little thing about this. Please, you know, water is known as a universal solvent, okay? So most times your problem is going to be, the solvent is going to be from water, okay? Now, in place of mass of solvent, or let's say for instance, mass of water, you can replace it with what? Volume of water, yes. So take note, the mass of water is equals to the volume of water. Most especially if the mass is given to you in grams, which is always in most cases, and that the volume is given to you in cm cube. Remember that the density of water is 1 gram per cm cube. That's the density of water. So if peradventure they gave us the mass of the water as 50 grams, by the time you solve using your formula for density to calculate for the volume, because what you have here, or if they give you the volume of the, well, let's assume they give you volume as 50 cm cube, and you are looking for the mass, because what you have here is mass of solute over mass of solvent, okay? If they give you only the volume and you are looking for the mass of the solvent, you can easily recall that your density is 1 gram per cm cube, okay? If the density of water is 1 gram per cm cube and this is the volume given, remember that density is equals to mass over volume. Now, if you are looking for mass, you can say mass is density times volume, and that will make us to have mass of the water or solvent will be what? 1 times 50, and that will still give us 50 grams. So if you watch very well, you see that the volume of water is equals to the mass of water. So if they give you volume in place of mass, just put into this formula, you still get the same answer. You don't have to worry yourself to calculate for mass. So that's why I said mass of the solute over mass of the solvent or volume of the water, if it is talking about water. Otherwise, you will have to get the density of the solvent and then solve this way to get the mass of the solvent. So in most cases, because your water is a universal solvent, okay, it is always water in solubility problems. So what you simply do is that they give you the volume, put it as the mass of the solvent, and then you get your answer. So we have two basic formula here to determine the solubility of a substance, either in mole per dm cube or gram per dm cube. Write this formula down so that if you take your past question, you will to solve problems involving solubility of substance. Okay, so if you watch very well, you will see that we were told to calculate for the solubility in mole per dm cube. So because we are looking for solubility in mole per dm cube, it therefore makes question formula 2 to be what? Irrelevant. So what we are going to use is formula 1, because formula 1 is the formula used to calculate for solubility in mole per dm cube. So let's take off formula 2 so we can solve the question. Like I told you, if you have 1000 here, your volume here must be in cm cube. Please take note of that. It must be in what? Cm cube. So what do we do? Very easy. Do we have the mass of the solute? Yes, they gave us 117.0 gram. This is the mass of sodium chloride that was dissolved. The volume of the solvent is 1 dm cube. So remember, volume is 1.0 dm cube. So what do? Because your volume must be in cm cube, you multiply with 1000, and that will give us 1000 what? Cm cube of the solvent. Now, very simple. So if we already have the mass of the solute that dissolves as this, and we have our volume, what we need now is the molar mass. So let's calculate for the molar mass of sodium chloride, which is this one. Okay, so molar mass of your sodium chloride will be equals to, remember, sodium is 23, okay, 23 plus chlorine is 35.5, and that will give us 58.5 grams. That's the molar mass. So if you're looking for solubility now, we have gotten our answer. Solubility in mole per dm cube will be equals to the mass of the solute that dissolved, which is this, 117 over molar mass 58.5 times 1000 all over the volume. The volume is what? 1000. So this one, we go this one. You are left 117 over 58.5, and that will give us 2.0 mole per dm cube. Wow, very cheap. Take note of this. Write the formula down. Use it to solve soluble problems in your forthcoming examination. So our answer is not C, it is not D, it is not A. Our answer is what? B, in 2 mole per what? dm cube. Wow. We have some other interesting questions at number 26, 27, and number 28. The Vulcanizers solution is prepared by dissolving rubber in words. How is Vulcanizers solution prepared? That is used for amending tires. Vulcanizer solution is prepared by dissolving, write it down. Vulcanizer solution is prepared by dissolving rubber and other substances in benzene. You dissolve rubber and other substances in benzene to prepare vulcanizer's what? Solution. So the answer is not ethanol, the answer is not kerosene, the answer is not petrol. Now, for the purpose of detail, I will not have you ignorant on this. Remember, there's what we call tincture of iodine. There's what we call tincture of iodine. What is tincture of iodine? Tincture of iodine is a solution prepared by dissolving iodine in ethanol. That's what gives us tincture of iodine, and it's used to clean wounds, okay? Now, for kerosene is a non-polar molecule. Petrol is a non-polar molecule. This one is a polar molecule because it contains the hydrogen bond, so it's soluble in water. This one is not soluble in water. All of these are non-polar apart from this. But the question is saying, how can vulcanizer solution be prepared? It is prepared by dissolving rubber and other certain substance in benzene. So the answer is what? Benzene. Please take note of that. Remember I told you in our last lesson that your carbon disulfide, okay? I told you that sulfur, the only inorganic compound that can dissolve sulfur is carbon 4 sulfide. Otherwise, sulfur is insoluble in all inorganic compounds apart from this. Now, the other organic compound that can also dissolve sulfur is your benzene. Is it only benzene? No, we still have methyl benzene, also called toluene. Okay, thank you very much. Let's go to the next question. The uncovered raw food sold along major road is likely to contain some amount of that. It is actually not good to buy uncovered food that is sold along major road because it contains a deposit of lead, Pb, lead, Pb. You know, lead is a heavy metal that even in trace amount can cause lead poison. So food that are sold along the roadside that are uncovered should not be consumed because of the deposit of lead that is gotten from the exhaust of automobile. Stay with us in this channel because we have other questions too. Continue. Yeah, the hydrocarbons used in the production of styrene is what? What is the hydrocarbon used in the production of styrene? Now, let's talk about styrene. Okay, what is styrene? Can you get your pen and jot this down? Styrene is also called phenylethene. Styrene is also called phenylethene. Phenyl is the other word for the array. Remember, when an aromatic compound like benzene loses one hydrogen atom, it will be called phenyl or the array. Okay, and the array is usually drawn in this order like this. It is usually drawn in this order. You know, there's supposed to be a hydrogen here, a hydrogen here, 1 here, 1 here, 1 here, 1 here. Okay, so that the number of carbon atoms will be 6 and the number of hydrogen atoms will also be 6. Okay, now if you put all your hydrogen here, it is called benzene. But if you remove one of the hydrogen, it will be called phenyl. Okay, it's called phenyl. So if I do it this way, I put this way, put here, put here, put here, and put here. It is referred to as phenyl. It is, let me make it bold, it is referred to as phenyl. Take note of that. So what you call alkyl for aliphatic hydrocarbon is what we call phenyl for aromatic hydrocarbon. Remember, the structure of benzene was coined by a scientist called Augustin Kekule in the year 1865 after he saw a snake that swallowed his own tail in his dream. So he came out with this structure, the hexagonal structure of benzene. So if a benzene ring loses one hydrogen, is called phenyl, or you call it the array. Okay, now this 18, you can just add 18 here, double bond, something like this. You can put CH, double bond, CH2. Okay? Yeah, you can do it this way. This compound is called phenyl. This one on its own is the 18. Okay? So if we put together, we'll call it phenyl 18. So take note of this. It is either called phenyl 18 or it is called styrene. So when the question says that the hydrocarbon used in the production of styrene is what? It's very simple. You need phenyl and you need 18. So we have to look for phenyl and 18, or basically benzene and 18. Benzene and 18 will give us phenyl 18, also called styrene. A repeating monomer of phenyl 18 is called polyphenyl 18, also called polystyrene. Okay, so let's look at the options and see our answer. The carbon used in the production of styrene is that 18 is not there. Our answer is 18. It is not ethane, it's not propane. It's 18 plus benzene that give us styrene or phenyl 18. Thank you very much. Now the next question, number 30, is said the acid used in the electrolysis of water. The acid used in the electrolysis of water is diluted with what? What's the acid used in the electrolysis of water. Remember the Hofmann voltameter, that Hofmann voltameter that involves the production of hydrogen and oxygen gas, okay? Hofmann drew a voltameter that has to do with the industrial production of hydrogen and oxygen through an electrolytic process. And the acid that was used in that particular experiment was H2SO4. So if you want to acidify water like the one Hofmann did, you must use H2SO4 to do that. Thank you very much. Let's go to question 30, number 1. Now, copper 2 oxide plus hydrogen gives us copper. Remember that copper is a solid and H2O, which is a liquid. They say, what is the effect of increasing the pressure on the equilibrium reaction above? What is the effect of increasing the pressure in the equilibrium reaction above? Please, I want you to jot this down for me. There are 3 factors that affect a reaction in equilibrium. Write that down quickly. Factors affecting reactions in equilibrium. What are the factors affecting reactions in equilibrium? Number 1 is called temperature. Number 2 is called pressure. And number 3 is called concentration. Catalyst has no effect in a reaction which is in equilibrium. We have factors affecting reaction in equilibrium. We also have factors affecting the rate of chemical reaction. Factors affecting the rate of chemical reaction. The rate of chemical reaction. These two stuff, they are different. This one is a reaction in equilibrium. For factors affecting the rate of chemical reaction, we have number 1, we have temperature. Number 2, we have pressure. Number 3, we have concentration. Number 4, we have nature of the reactant. Nature of the reactant. Number 5, we have light. Number 6, we have catalyst. And number 7, we have surface area. So these are the 7 factors that affect the rate of chemical reaction. But the factors that affect the reaction in equilibrium differs from this. So take note of this. There are only 3 factors that affect the rate of chemical reaction in equilibrium, which are temperature, pressure, and concentration. Catalyst is not here. Catalyst has no effect in the reaction which is in equilibrium, okay? It only increases the rate at which the equilibrium is achieved, but it cannot decide the direction where the reaction is going to proceed to. Now, in this particular question, they say, what is the effect of increasing the pressure on an equilibrium reaction above? What is the effect of increasing the pressure? Now, the condition for pressure to affect a chemical reaction is that number 1, the number of moles in the left-hand side must never be equal to number of moles in the right-hand side. That's number 1 condition for pressure to affect a chemical reaction. Number 2 condition for pressure to affect a chemical reaction is that the reactant and the product must involve gases only. So if you look very well, you will see that this one is a solid. Okay, this one is a gas, this is a solid, this is a gas, this one is another solid, and this is a liquid. So because of the fact that the reactant and product does not involve gas only, the answer to this question is that pressure will have no effect. Pressure has no effect. So the answer can never be A, the answer can never be B, the answer, there is no effect. That is the answer. Answer is what? C. Please take note of that. We have more questions for you. Remember, we are dealing with the Jamb more questions. We are in number 31. So stay to the end of this video because we want to finish the 40 questions that came out in your Jamb mock 2024. Okay? This guy is called ethane. Okay? The combustion of 1 atom of oxygen of ethane will give us ethanol. According to the question, they say from the reaction above, calculate the heat of reaction in kilojoule per mole. If the standard heat of formation of ethane, this is your ethane, and your ethanol are this and this, okay? It's very easy. Remember that this is your reactant, while this is your product. And the enthalpy change is giving us, your enthalpy change is giving us the sum of the heat content of the product minus the sum of the heat content of the reactant. So from the equation above, your ethanol is your product, while your ethane is your reactant. So what is the heat of formation for ethanol? Remember they said ethane and ethanol are this and this. So ethanol is minus 325.5. Then minus your ethane is minus 150.5. This is the minus from the value. Why? This is the general minus that comes with the formula. So we have minus 325.5. Minus minus will give us plus 150.5. And that would end up giving us minus 325.5 plus 150.5 will give us minus 175.0 kilojoule. So the answer to this question is option B. Let me use my calculator to confirm it. Minus 325.5 plus 150.5. Wow, that's correct. Minus 175.0 kilojoule. Now let's take the next question. The simplest branch chain hydrocarbon is what? Please, when they are talking about branch chain hydrocarbon, they are talking about alkylation and hydrocarbon that can exhibit isomerism. And you should know that from the structure of alkane, your isomerism begins from the fourth member of the alkane homologous series. Remember, your alkane homologous series is beginning with methane. Methane is CH4, then you have ethane. Ethane is C2H6, which can be written as CH3. This one is written as CH3.H. CH3.H. Then if you have propane, your propane is written as C3H8, which will give us CH3, CH2, CH3. Then when you have butane, your butane is C4H10, which will give us CH3, CH2, CH2, then CH3. This is your butane. Now, you can only be able to branch this. This is the only guy, the first guy that can undergo alkylation. It means alkylation means the conversion of straight chain hydrocarbon to branch chain hydrocarbon. You cannot overlap this carbon because it's just 3. Okay, but you can overlap this carbon to give you CH3, then you have one CH3 here, then you have another CH3, and then you have H here. This will become your longest continuous chain called propane. While this one is your methyl. So we can say that if you number the carbon atom, you have number 1, number 2, number 3. So we can say it is 2-methyl. 2-methyl what? This guy is called what? Propane. So take note of this. The simplest branch chain alkane is not ethane. It is not ethane. This one is not even a member of the alkane homologous series. This is a member of the alkene. So it's not even part of the option. Propane, no. The answer is butane. The simplest branch chain alkane is what? Butane. Question number 34. Now, what does 34 say? It said the IUPAC nomenclature of the compound above is what? Some of you saw this in your Jamb exam. What is the IUPAC for this compound? Very easy. Now, among the rules for naming hydrocarbons, remember that if you have this particular compound, this happens to be your functional group. And if you have a functional group, your counting should begin from the functional group, okay? So if this is our functional group, we have a compound like CH3, which is this. Then you have, if you condense this together, you have CH, then you have a CH3 here, then you have CH2, then you have CH, then you have CH2. So our numbering 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The longest continuous chain should be identified, which can either be this way or straight. So if we take this one as our longest continuous chain, we number from here, not from here. Okay? Because the functional group is here. So if there was no functional group, we would have started counting from where this methyl is. So let's start from here. You have 1, 2, 3, 4, 5. Wow. Now, this long chain is called pent 1-in. Why is it pent 1-in? It's pentene normally, but because the double bond is found in the first carbon, we have to identify it to say it's pent 1-in. If the double bond was found here, so that we call pent 2-in. Are we together? Okay. Now, if this is pent 1-in and this guy is methyl, we can name this compound by first identifying the position of the methyl. Methyl is at the 4th carbon, so we say it is called 4-methyl. 4-methyl. Then you attach the parent name pent 1-in. Okay, for instance, I'm giving you this one as your assignment to name for me. What is the name of this compound? I guess you will start counting from here. Yes, you are very correct to start counting from here. Why do you start counting from here? Because the double bond is closer this way than this way. So if you want to name this compound, now without disputing the fact that this is our longest continuous chain, this guy is called pent 2-in because the double bond is at the 2nd carbon and this is your methyl. So this is called 2-methyl pent 2-in. That's the answer. Pent 2-in. Thank you very much. Let's quickly rush the other question. We just have 6 questions left. I might decide to give you the other question as your assignment, or we just do 3. No.
Action, boss.
Wait. Okay. Hey, boss! Yeah. 35. Iron can be protected from corrosion by coating the surface with what? Iron can be protected from corrosion by coating the surface with what? Remember, for you to protect a metal, the metal used for the protection must be more reactive than the metal. And you should remember in your electrochemical series that we have potassium, which we call Kate never can marry Alhaji Zino for sin, lead, and hydrogen commit mercury, silver, gold. Now, we are to electroplate iron. Iron is LFE, which is this one. For you to electroplate iron, you need a metal that is more reactive than iron. Okay? So if there was potassium there, that would have been the answer. If there is sodium, it would have been the answer. If there is calcium, it would have been the answer. So the answer to this question is zinc, because zinc can protect iron. See, because zinc is more reactive than iron. So the answer is word C. Now, hematite is an ore of what? Remember in our previous lesson, I told you that hematite is an ore of iron. So the answer is word C. If the silver mirror test is positive, it indicates the presence of what? Remember, we have 2 particular families that share some similarities and differences. And these organic families are alkana, also called aldehyde, and alkanon, which are also called the ketones, or you call them the ketonic acid. If you want to distinguish alkana from alkanon, you either use Fehler's reagent or Tollin's reagent. And alkana usually shows a positive test to both Fehler and Tollin's reagent. So the answer to this question is that if you have a silver mirror test, remember your silver mirror test is also called your Tollin's reagent. It's also called your what? Tollin's reagent. And if you have your Tollin's reagent and it shows positive, you must know that an alkana is present. I think this option B is alkana. Why this one is alkano? So the answer is alkana. Alkana shows a positive test to your silver mirror reagent, which is also called the Tollin's reagent and your Fehler's reagent. Now, question number 38. The saponification of an alkanoid. Remember, alkanoid is also called an ester. The saponification to produce alkanol involves dash. Very easy. I think I should just give a little illustration on this. Just a little illustration. Don't get distracted. Just Now, if we have esters, which is also called alkanoate, plus caustic alkali, what it will give us is soap plus your glycerol. Your glycerol is also called alkanol. So take note, the saponification reaction that involves the production of soap is also called alkaline hydrolysis, because the caustic soda or caustic alkali, which is your sodium hydroxide, hydrolyzes this compound to give us soap and glycerol. This glycerol is an alkanol having 3 functional group called propane 1, 2, 3 what? Triol. So the other name for saponification reaction, is also called alkaline hydrolysis. If it is water that is used in this reaction in place of caustic soda, it should have been called just hydrolysis. But if you have an alkali, it's called an alkaline hydrolysis. And if you have an acid like ACl in the hydrolysis of maltose or sucrose or lactose, it will be called acidic hydrolysis. So as for this one, it's called an alkaline hydrolysis. So take note of that. The other name for saponification is called alkaline hydrolysis. Question number 39. I'm going to give you the formula, then you solve it yourself. Calculate the number of moles of ACl present in 20 cm cube of this particular concentration solution of the acid. Very easy. Remember, in concentration, number of moles is CV over 1000. This is the formula used to calculate for number of moles when it involves concentration. So your concentration is 0.75 mole per dm cube. That's what the capital letter M stands for. Your volume is 20 cm cube. By the time you multiply these two and you divide it to 1000, you get your answer. Let us quickly do that. We have 0.75 times 20 divided by 1000. You have 0.015 mole. The answer is what? D. Now, finally, we have come to the last question of your Jamb question 2024. The molecular formula of an organic laboratory anesthetic is what? The molecular formula of an organic laboratory anesthetic is what? Remember, your anesthetic are usually used in surgical operation. Anesthetic is usually used in surgical operation. And this anesthetic is also called chloroform, which is CHCl3. The name is called trichloromethane. But due to the poisonous nature of this compound, it has now been replaced with another compound called your laughing gas, which is dinitrogen 1 oxide. Dinitrogen 1 oxide. So it's either we use this one. This one was the old anesthetic, but this is the recent anesthetic. But the question has only this in the option. So the answer to this question is option A. Thank you very much for staying with us in this YouTube channel. This is the H2O Spirit channel. Please, if today is your first time for coming across our video, do not forget to subscribe. Also, please help us to like and comment. Tell us what you feel about this Jamb question 2024. Thank you very much. I'll see you in my next video.